rectangles and trapezoids. So the area of a rectangle is pretty simple. It's the area formula that you learn in elementary school, which is length times width. Versus the area of a trapezoid is the 1/2 times B1 plus B2 times height. So if we're doing a right point approximation, I always like to use the rightmost y values in each interval. So on this one, let's say that we have 4 rectangles. So if we want to find the width, I always like, just doing the total interval divided by the number of rectangles. So that width is equal to 1/2. And when I'm setting up the calculation, I say area is equal to 1/2. So all of the rectangles have 1/2. So I like to distribute that 1/2 to all the heights of the rectangles that I find. So if I'm starting on the right point, I'm going to when I look at this right interval here, I'm going to choose between 1.5 and 2. And I choose 2 and its y value. And then I'm going to choose between 1 and 1.5, 1.5's y value. So maybe, let's see, that y value is 5. This one's maybe about 3.5 or so. Then we have between 0.5 and 1, we choose that y value, which is 2. And then 0.5's y value is the last one that we choose. And that's about, 1.25 or so. Now, if you have the function itself, you can always go to the graphing calculator and make a table of values for the different values that you used. But on the test, I'm just going to give you the graphs. And then we're just going to add. So I then go to my calculator and add them up. So I get 1.25 plus 2 plus 3.5 plus 5. And that gets me 11.75 divided by 2 for a total of 5.875. Now, the benefit of a rectangle is the geometric formula for this is really easy. It's length times width. And we even, are able to keep the width the same and take out that half and just sum up the y values for each rectangle. The drawback is, especially with, a relatively few number of rectangles like what I have, is that the right point has kind of a overestimation. So we can kind of see that those rectangles are jutting up above. Now the left point, I'm not going to go in detail about how to compute this, but what I am going to go in detail with is, how to draw it. So I start from the left side, I choose 0's y value, then I choose 0.5's y value, 1's y value, and 1.5's y value. And we can see here that we have an opposite problem. And the opposite problem is that we have an underestimation. Now, I'll just go to my calculator real quick and compute its area, and you can kind of try the computation on your own. But at the end of the day, you should have something like maybe around 3.875. Now, the midpoint is kind of a nice compromise. So we can see here that we have overestimation with the right point, underestimation with the left point. So the midpoint is a really nice compromise. So if I go and choose between 0 and 0.5, I'm going to choose neither. I'm going to choose 0.25's y value. And I like to draw a little dotted line there. Then I go between 0.5 and 1. And I'm going to put a dot right there. I'm going to go right between 1 and 1.5. A dot right there. And then I'm going to choose kind of between 1.5 and 2. It's about right there. That's a little overshot there. And then we go choose that midpoint right there. It's called the midpoint because we're just choosing the midpoints of each little subinterval. And we can see that each rectangle kind of has a part that overestimates and a part that underestimates. And in pretty well-behaved curves, you're going to see that underestimation and overestimation, pretty well cancel each other out. And you're just going to take like those y values and estimate them. So maybe I have 1.1, maybe something like 1.7, 2.6 maybe, and 4. And this will give us more what the real area of the curve is. So I won't do the computation in detail because it's similar to the right point. Divide by 2. Okay. So I got about 4.7. So if we are to guess what the area is, I would say it probably is, in that high 4 range. Now, you can improve rectangles by, maybe doing more rectangles. So if I did like every quarter instead, and I'm just going to erase all these and kind of show you the more rectangle approach. Hey, it's just like my board. Oh man, this is just like at home. Just as if we're, erasing the board in an old classroom. Yeah, so if I did like a right point with more intervals, like if I did 8, you can kind of see that the estimation issues let me just make sure we're actually right point. I'll just start over here from scratch. But we could kind of see here that the estimation issues that we had with the overestimation become a little bit less severe, but still not ideal. I mean, there's still, a substantial amount of overage. So the solution that we have is doing what's called a trapezoidal sum, where you can still do, just a few geometric shapes, but do the area of a trapezoid instead. So kind of the appeal for that is that you're taking the average between the two y values, and it's kind of counterintuitive because your bases are actually the sides of the trapezoid rather than the top and the bottom, because these are trapezoids on your sides. So what I would do, like when you're setting up your calculations, is, I just kind of make a list. So like for region 1, I call this half. The width is a half. And then I do like 1 plus 1.1. And then the second one, and we can kind of see that the trapezoid does a nice job of like really minimizing that white space. Maybe we do like, half times 1.1 plus 2. And then the third rectangle, or not rectangle, but trapezoid, I do half times 2 plus 3.25. And then the last one, I do half times 3.2 plus 5. And my suggestion with these is just taking it one at a time. So a lot of people who do a good job of mastering the trapezoidal, just do one trapezoid at a time, stay true to the formula. Now, my formula rendition, I just kind of did the half h times b1 plus b2 instead. And then you just take it one at a time. So like if I'm doing trapezoid number 4, I go to my calculator and I compute the area of that individual trapezoid. So maybe that trapezoid, its area would be 2.05. And then I just total up the other ones. So like for trapezoid 1, if we're kind of checking our work, let's see, trapezoid 1's is going to be 0.525. Trapezoid 2, 0.775. Trapezoid 3, 1.3, and then 2.05, and we just total those up. And at the end of the day, wait for it, drum roll, drum roll, drum roll. We get 4.65, kind of in that high 4s that we were talking about.